Hi folks, welcome to 6.4 multiple angle formulas, and we are on part 3 of our video. So here we're going to talk about half angle identities. Now these half angle identities are also known as power reducing formulas. Okay? And that might be a more common name than what your textbook uses, but I wanted you to know that they're the same. Now, the reason why they're called power-reducing formulas is because if you look at this first formula for sine, it's sine squared. But when you look at the other side of the formula, there's no squared. So we went from something with a power of 2 to a power of 1. Let's see if that holds true for cosine. This is cosine squared, and this is tangent squared. And when we look at both of the other sides, I see a power of 1, power of 1, power of 1. And so that's why we call them power-reducing identities. They make our powers get smaller, and we tend to use this a lot in calculus. Okay. So let's take a look at this example from your book. I actually thought it was a quite good example, and so we can call this one example 1 for this section. And we're going to verify this identity. Now, they took the left-hand side and tried to make it look like the right-hand side. And so what we can do here is we can take our sine squared, and instead of writing sine squared, we can sub it out with the half angle identity or the power reducing identity. And we can do the same thing with our cosine squared. So cosine squared is going to be the same as 1 plus cosine 2x over 2. And now when we FOIL these, we'll see that the 2 and the 2 are on the bottom, and that's how they get this 1/4. And then they take the top, 1 minus cosine 2x, and they FOIL it with 1 plus cosine 2x, and that's where they get this 1 minus cosine squared 2x. They multiplied, or we can think about it like FOIL. Okay. Now, they were able to take 1 minus cosine squared and say, hey, that's like part of the Pythagorean identity. And so instead of writing 1 minus cosine squared, this 1 minus cosine squared became sine squared of 2x. And what we see now is we can actually use our half angle identity again. And so when we use this half angle identity, and I'll go back to the pink because it's the same as the sine squared x in the beginning, we get the 1 minus cosine 4x, because that angle has to be twice as big, over 2. And from there, I get this 4 times 2 on the bottom gives me a 1/8, and then I have the rest of that identity in as just the part without the constant, okay? So a good example of using the half angle identity, or again we call it the power reducing identity, and you can use that more than one time in the same proof, and that's okay. Okay, let's take a look at, we'll call this example number 2. So express cosine to the 4th in terms of the cosine function with an exponent of 1. And this is actually really useful, again, when you get to calculus, and mostly in Math 151. Okay, so that'll come back up again in Calc 2. So first, we're going to rewrite the power of 4 as something squared, and we can do that using the law of exponents. Then, we're going to replace cosine squared t with the power reducing formula here. And so we'll get 1 plus cosine 2t over 2, that whole thing squared. Now you're going to square it, or you're going to FOIL everything out. And when you FOIL everything out, just like last time, I realize that I have another cosine squared, and so I can use the half angle identity one more time. And then the only thing left to do is to distribute this 1/4 to all three terms. And so we'll get 3/8 plus 1/2 cosine 2t plus 1/2 cosine 4t. Now if you're like, oh, where did that 3/8 come from? It came from this 1/4. And then you have 1/4 times 1/2, okay? So 1/4 plus 1/4 times 1/2 will give me 1/4 plus 1/8, which will give me that 3/8. Okay, so again, this is more useful a little bit later on, but it's good to introduce it right now. Now, for our third topic here, we're going to talk about half angle formulas. And with the half angle formulas, what they allow us to do is to change something that is with a whole angle, like cosine V, cosine V, cosine V, cosine V. Those are all whole angles, and we can convert them to a half angle, or a half angle, or a half angle, okay? We're going to go through a couple examples of how to use this, but I did also want to include two other options for the tangent half angle formula. And again, the multiple versions of the formulas are really just so that you can see which one might work best in a given scenario, okay? And I hope the choices don't feel too overwhelming. It's okay if they do, but again, the more you practice, the more you're like, okay, well maybe if this one doesn't work, maybe I try this other one. Okay, so let's take a look at our half angle formula questions. Example 1. If secant theta equals 5/4 and theta is in quadrant 1, find the exact values of sine of theta over 2, cosine theta over 2, and tangent theta over 2. And so because I know that theta is in quadrant 1, I'm going to go ahead and draw my right triangle facing like it would in quadrant 1 and label that bottom corner as theta. Now secant is the opposite, or the reciprocal, of cosine. So I know that the top number represents the hypotenuse and the bottom number actually represents the adjacent side. So I can say that the hypotenuse is 5 and that this bottom side is 4. Now we've seen this triangle a lot, the something 4, 5, and it's going to be a 3, 4, 5 right triangle. And now we can just plug things into our formula. So for sine of theta over 2, we can say that that is going to be the square root of 1 minus cosine of theta, or 4/5, and that's divided by 2. And I'm going to get the square root of 1/5 divided by 2/1, which is going to give me the square root of 1/10, or I can say 1 over the square root of 10. Now, if my angle is in quadrant 1 and I take half of my angle, that angle is still going to be in quadrant 1. And so I know that sine is going to be positive, and I can leave it like that. Let's take a look at cosine. So cosine of theta over 2 equals the square root of 1 plus cosine (1 plus 4/5, over 2. And that is going to equal 9/5 over 2/1, which is going to give me square root of 9/10, or 3/√10. Now again, I know this is positive because when I find a cosine of an angle in quadrant 1, it's positive. All right, let's find that tangent. Tangent theta over 2 is going to give me my sine theta over cosine theta. And those root 10s cancel out, and I'm just left with a tangent theta over 2 of 1/3. And sine and cosine and tangent are all positive in quadrant 1, so those are my 3 answers. Okay, in our last example here, I want to talk about making decisions about how big an angle is before we even get started, okay? So I know that my theta in this case is in quadrant 3. So to me, that means that my angle is between 180 and 270 degrees. Now, let's think about what that means for theta over 2. Well, let's take 180 divided by 2, I get 90. And 270 divided by 2 gives me 135. Now, which quadrant is this in? Well, that's in quadrant 2. And that means that sine is positive, cosine is negative, and tangent is negative. So I like to make this decision before I even start the problem, so I just put the right sign with my answer at the end of each answer. So let's draw our triangle here. In quadrant 3, I've got my theta, and I know tangent is opposite over adjacent, and if I use a squared plus b squared equals c squared, I will find the hypotenuse to be the square root of 2. Okay, let's find our half angles. Sine of theta over 2 equals the square root of 1 minus cosine. Now cosine here is negative, so negative 1 over root 2 all over 2. And when we clean this up, we will get root 2 plus 1 over root 2 all over 2 over 1. And that is going to leave me with root 2 plus 1 over 2 root 2. It's okay for you to leave your answer like that. Okay, let's find our cosine half angle. Cosine of theta over 2 equals the square root of 1 plus negative 1 over root 2 all over 2. Now I know at the end it's going to be negative, so I'm going to put that sign here now so I don't forget. Equals negative root 2 minus 1 over root 2 all over 2 over 1, which gives me negative root 2 minus 1 over 2 root 2. All right. Last but not least, let's finish off with our tangent half angle. Now I know at the end I want to have a negative answer because I said earlier that tangent needed to be negative. And so all I'm going to do is take my sine and divide it by my cosine. And so I will get the square root of root 2 plus 1 over the square root of 2 root 2 all over the square root of root 2 minus 1 over the square root of 2 root 2. And these two cancel. And so I will be left with a negative root 2 plus 1 over root 2 minus 1. And as messy as that is my answer. And that's where we're going to stop here for 6.4. If you have any questions, shoot me a message and let me know, and I'd be happy to help you out. Thanks so much.